Before we start multiplying polynomials, we first need to look at the product rule for exponents. Say, for example, we had a to the m times a to the n. Remember that if the bases are the same, then you add your exponents. So that would give us a to the m plus n. Now the bases have to be the same, and then we can add our exponents. So for our first example, let's look at negative 2x y to the fourth times 9x to the fourth y to the sixth. We need to look at our common pieces, and as long as the bases are the same, then we can add our exponents. So let's start with the pieces that we can do. It's all multiplication here, so we can do negative 2 times 9. Negative 2 times 9 gives us negative 18. I have x to the first, and I have x to the fourth. So x to the first times x to the fourth would look like x to the 1, x to the fourth. 4 plus 1 is 5. So x to the fifth. I have y to the fourth and y to the sixth. So that would look like y to the fourth times y to the sixth. 4 plus 6 is 10. Let's try again. A to the second, b to the third c times negative 3 a b c. So I have 5 times negative 3, that gives me negative 15. A to the second, a to the first, that's going to look like a to the second, a to the first, so that gives me a to the third. B to the third, b to the first, will look like b to the third, b to the first, and that gives me b to the fourth. C to the first and c to the first, that looks like it will give us c to the second. Let's try some more. Three x to the fourth times 2x y to the second plus 5x to the seventh minus 9y. Now this time we have a polynomial right here. We have a monomial here, there's no addition or subtraction. But then we have a trinomial here, a 3-piece polynomial. So that means that we want to consider our distribution. So if we distribute this to each piece, then we will be able to simplify it down. So looking at the first piece, we have 3x to the fourth times this first term, 2xy to the second. So 3 times 2 gives us 6. X to the fourth, x to the first, 4 plus 1 is 5, so x to the fifth. And y to the second comes along for the ride. There's no y's right here. So then we have 3x to the fourth times 5x to the seventh. A positive 3 times a positive 5 gives us positive 15, so plus 15. X to the fourth times x to the 7, 4 plus 7 is 11. And then we have 3x to the fourth times negative 9y. 3 times negative 9 is negative 27. I can't do anything with x to the fourth and y, so we just have x to the fourth times y. Let's try another one. So same idea. We need to distribute this monomial to each piece of our polynomial. So we have 1/2 times 4, negative times a positive gives us negative 2. We have m to the second times m to the first. 2 plus 1 is 3, so m to the third. We have n to the first and n to the first. 1 plus 1 is 2. And then we have our negative 1/2 times negative 8. A negative times a negative gives us positive. 1/2 times 8 is 4. m to the second times m to the second, 2 plus 2 is 4, so m to the fourth. But don't forget this n right here. There are no n's to combine it with, so it just tags along. Negative 1/2 times positive 10 gives us negative 5. M to the second, there's no m's, that's okay. N to the first, n to the second, 2 plus 1 is 3. Let's try again. So those examples had a polynomial in the front, which means that it was just one piece. So let's look at one where we have a binomial. A binomial means two terms. So when we look at a binomial, oftentimes you hear of the acronym FOIL. FOIL means first, outer, inner, last. So first means you multiply the first and the first. That's the F. O means the outer. You multiply the outside to the outside. I means the inner. So you multiply the inside, two pieces. See how it makes a little smiley? The 1 and the 7 are the eyes and a big smiley face. That's because you're halfway done. And then L is the last. So you multiply the last one in each parenthesis. So if we try to FOIL this, we have to look at our first, our outer, our inner, and then our last. And then once we do that, we'll combine any like terms that we have and simplify. So the first gives us 2x times 7x. 2 times 2 times 7 is 14. X times x is x squared. Next we need our outer. So the outer is 2x and 5. So 2x times 5 gives us 10x. Now we need the inner. So that negative 1 and that 7x. So they make a little smile because we're halfway done. Negative 1 times 7x is negative 7x. And then our last, we have negative 1 times positive 5, and it gives us negative 5. So if you notice, right here in the middle, we have some like terms. They're not always in the middle, often, but not always. But look to make sure that you simplify any like terms. So if we combine our like terms, we have 14x squared. 10 minus 7 gives us positive 3x, and then minus 5. Let's try some more. Now this time, it's not quite the same acronym as FOIL because we have a trinomial here instead of a binomial. But we're looking at the same idea of multiplying each piece from the first parenthesis times each piece in the second parenthesis. Sometimes you can think of it as distribute. Essentially, you're distributing each piece of that first binomial to each piece of that second trinomial. So let's try. X times 2x gives us 2x1 plus 2 is 3. Now stick with this one. Take that x and multiply it by each piece. So x times negative x gives us negative x squared. So essentially a 1 and a negative 1. So 1 times negative 1 is negative 1. 1 for the exponents. 1 plus 1 gives us 2. X times negative 8 is minus 8x. Now we're finished with the x. We've multiplied it through to each piece. Let's try the 3. 3 times 2x squared. 3 times 2, that's 6x squared. 3 times technically negative 1. So 3 times negative 1 is negative 3x. and 3 times negative 8 is negative 24. And we have a couple like terms in this one that we can simplify, so let's make sure that we simplify our like terms. So here I have an x to the second, here I have an x to the second. So that's going to have our 2x to the third. We have 1, we have 6, so negative 1 plus 6 gives us 5. Here I have an x term, here I have an x term. So negative 8 plus negative 3 is negative 11, carry our x, and it looks like we just have minus 24. Let's try some using our function notation. So let's say that we are given f of x equals 3x and g of x equals 6x minus 8. So let's find f times g of x. So what that means is we want to find f of x, so in this case 3x, and multiply that by g of x, which in this case is 6x minus 8. So if we multiply these together, that means we are going to distribute that 3x from our monomial to the 6x minus 8 binomial. So 3 times 6 is 18. X times x is x squared. 1 plus 1 is 2. And then 3 times negative 8. And that's going to give us negative 24. There's no x's here, so the x carries along. Let's try again. Let's say this time that f of x is x minus 7 and g of x is 4x plus 5. So if we want to find f times g of x, that means we're looking at f, which is x minus 7 from right here, times g, which in this case is 4x plus 5. And we'll need to use our FOIL property for this one. So FOIL tells us that we take the first times the first. So x times 4x gives us 4x squared. And then we have the outer. So we have our x times our 5. So that's positive 5x. Then we have our inner. Make that smiley face because you're halfway done. So negative 7 times 4x is negative 28x. And then you have that last, that negative 7 times the positive 5, which is going to give us negative 35. Here you have some like terms right here in the middle. So let's clean those up. We have 4x squared. Positive 5x minus 28x is negative 23x. And then minus 35. Let's try a couple more. So for these next couple, let's say that f of x is x squared minus 9 and g of x is 2x. So let's look for f times g of 3. So in this case, instead of finding f times g of x, we're looking for f times g of 3. Well, let's do this the same way we've done the others. So f of x is x squared minus 9. G of x is 2x. So we can distribute our 2x. 2x times x squared is 2x to the third. Negative 9 times 2 is negative 18, and we bring down our x. Now remember, we're looking for the 3 right here. So that means we rewrite, but where we see the x, we put our parenthesis. And inside that parenthesis, we put our 3. So 3 times 3 is 27. So this gives us 2 times 27 minus 18 times 3. 2 times 27 is 54. 18 times 3 is also 54, so this simplifies to 0. Let's look at another one. See, we have f times g of -1. Well, we already found f times g, and we found that to be 2x to the third minus 18x. That's from right here. So let's go ahead and put in our parenthesis. And in this case, in that parenthesis, we're putting our -1. -1 times -1 times -1 is -1 times -2, so -2 minus -18 times -1 is +18. So that is going to give us 18 right here. And then we have -2 plus 18 gives us 16.